Hello everybody. Today we're going to use Manifold Viewer to hunt meteorites all over the world. We're going to open a project, File, Open, and it's this one here, let's scroll down, called Meteorites, meteorites.map. Click on that and then click Open. And that opens up a project that somebody else created in Radiant Studio. Manifold Viewer is a free product, there's no strings attached, it's not NAGware or limited time trial or something like that. It's a fully functional product. It is read-only, but it's perfectly capable of opening hundreds of different file formats and database formats and all kinds of other things. And it works particularly well with projects that have been created in Radiant Studio. I'm going to come here to this project here, to this component here called Map. I'll double-click it to open it. And that opens up a map that shows the entire world with locations of all the meteorites that have been found in the world that are part of the Meteoritical Society database of meteorites. Although Manifold Viewer and Radiant Studio are fairly technical products that are used primarily by people who are working with spatial data and database and GIS, if somebody else has created the project for you already in Radiant Studio, you can just double-click this and with very little technical skill at all, use it to do all sorts of wonderful things. So let's look at how to use Viewer. Let's cover the basics. If we right-click and drag and then release to create a box like that, Viewer will zoom into the region that we've indicated. If we left-click and then drag, we move the map. If we have a wheel mouse, which we should, we can use the mouse to zoom in and to zoom out. Now, the speed with which Viewer is redisplaying here depends primarily on what is in the background. The background map is a satellite map. It's this thing right here that's coming in from Google. Google's pretty quick, but all the same, if you're getting stuff in via internet, it has to pull in those tiles that it needs to read, and those tiles are coming in from some remote server. So that's going to take some time over internet. That's not as fast as if everything was in the map project itself, or in which case it would be instantaneous. What are we looking at here? Let's zoom out. And the way we zoom out, if we want, we can click on a layer and then view zoom to fit. And that zooms the entire layer. What we're looking at here is a Google satellite display of the entire world. It's kind of cut off down here right around the North Pole and South Pole rather, in Antarctica. And we have several layers. A map in Radiant or in Manifold Viewer has multiple layers. We have a layer here called Candidates. We can double-click layer to turn it on and off. We just double-click that off. We have one called Martian Meteorites. Well, let's turn off the meteorites later first. Double-click that to turn that tab off. And now what remains are the Martian meteorites. These are the locations of every meteorite that's been found on the planet Earth that's come from Mars. And they actually know it's from Mars because they can sample the chemical composition of the thing and isotopic balance and all that and confirm that piece of rock really did come from Mars. Typically, meteorites that come from Mars arrive on Earth because when a larger meteorite or asteroid has hit Mars and creates a crater, it blasts off part of the Martian surface, and some of that surface blasts off into space, and some of it comes back, comes traveling all the way through space and gets attracted by the gravitational field of Earth and ends up falling as a meteorite on Earth. And there's actually quite a few Martian meteorites, as we can right-click on and then choose Zoom. Quite a few Martian meteorites have been found on Earth. Most of them have been found in Antarctica. And there's also been quite a few lunar meteorites. Here are the lunar meteorites. We'll turn those on. We'll zoom that to fit. And many of these have been found in Antarctica and also in North Africa. Now, why have so many lunar meteorites, and for that matter, Martian meteorites and so many other meteorites been found in places like Northern Africa? The answer is that it's a lot easier to find meteorites, which tend to be dark rocks, if you're hunting on a background of a light-colored surface. If we're zooming into the entire world here to take a look at the entire world, as you can see, most of the world here is green. So it's a lot harder to find meteorites in places that are covered with a lot of plant coverage, such as forests and so on. So that gives us a strategy for how to find meteorites pretty much anywhere we might be looking in the world. The strategy is very simple. And let's take a classic example. Let's use the example of the United States. I'm going to turn on the meteorites layer here. I'll turn off the lunar meteorites layer. So it's just going to be all meteorites. And if we take a look here in the southwest United States, we see quite a bit of the United States is desert or otherwise devoid of tree cover. The best way to find meteorites, if you really want to be efficient about how you do this, is you go to a place where there's no ground cover, so that a small dark rock will stand out. And let me zoom back. Oh, by the way, we can also use these back buttons here to navigate as well. And I'm going to turn on a streets layer here, a semi-transparent streets layer that's from Bing. Great. The best way to find a meteorite, at least in the United States, is you go find yourself a dry lake bed where the lake has been dry for a few thousand years, and where the lake has a white surface to it. So let's take this lake right here. This happens to be Coyote Lake, by the way. And on this flat white lake bed, pretty much any black rock that's sitting on the surface is almost guaranteed to be a meteorite. Why? Because all the rocks around here, the native rocks, are like colored rocks. Meteorites, on the other hand, tend to be dark because as they come hurtling down through the atmosphere at high speeds, they heat up, and the friction causes what creates what's called a fusion crust on the surface of the meteorite. And that fusion crust tends to be very dark. So on a light lake surface like this, that's perfectly flat, a dark rock sticks out like a sore thumb. In fact, if you're driving around on one of these lake beds on a motorcycle or an all-terrain vehicle or even in a Jeep or a car, you can typically see a dark rock on the lake surface from quite a great distance, many yards or many meters. We're going to use this as an example of finding meteorites because our other user-friendly example, hunting archaeological relics in France, people started complaining that, hey, all your demos are about places in France, and as much as I like the wine country and chateau and all that cool stuff in France, I live in the United States, so give me something I can do in the United States. Well, here's something you can do, at least if you live in the anywhere near the Southwest. The way we're going to find meteorites in the United States is we're going to, I'm going to zoom out here using the wheel mouse. And I'm going to turn the transparent streets layer back on. And then I'm going to double click here on the so-called candidates layer. Now what's the candidates layer? Let's zoom to fit that. Candidates layer, I'm going to right click on that and then choose zoom. You can't see it because it's out of the recording screen, but I clicked on zoom. And what we have here is we've previously gone through here and we've put these little triangles to mark all the lakes where the dry lake looks nice and flat. It looks white, so there's plenty of so it's easy. It should be easy to see dark rocks on the lake, and ideally the lake is nearby some kind of street network. I'm going to turn on a non-transparent streets layer, so you can see that there's some roads and trails here which you can in State Highway 99. Which you can use to get to this lake, get to the area of this lake by car. Because the ideal way to go hunting for meteorites on these lakes is you don't want to mess around on foot with a metal detector. You want to be driving along in your air-conditioned SUV, slowly, crisscrossing in a regular pattern these lakes. And whenever you see a dark rock, which you can see from quite far off, stop, pull out your magnet, and see if the magnet attracts the rock. If it's a dark rock on one of these lakes and a magnet attracts it, and it's not obviously a piece of metal that's fallen off somebody else's SUV, you have a very good chance of having a meteorite on your hands. Now, it's true that a lot of the meteorites that are found on these lakes are not metallic meteorites. They're not made out of iron or have a high iron content or nickel, so a magnet won't attract them. And they're stone, so-called stone chondrite or stone meteorites. But even there, if you have a good eye, you can tell those. My point is that if you carry a strong magnet with you and it's attracted to that dark rock that you found, almost certainly you found a meteorite. So once again, let's zoom out to where all these candidate lakes are. I'm going to right-click on the layer, and then I'll choose in the context menu, zoom. And we can see there's a whole bunch of them. So if you're traveling here between, Los Angeles, Barstow, Las Vegas, you can see there's quite a few lakes that are in the region. Some of them have already been hunted fairly extensively. Coyote Lake, for example, has had a lot of meteorites found there. That's okay, because meteorites are often found in clumps, and that's another one of the most successful things you can do to find meteorites. Go look for meteorites where people have already found meteorites. And why does that work? That works because as a meteorite hits the upper atmosphere and starts heating up, quite often it breaks apart into smaller chunks. And those smaller chunks fall in an ellipsoidal pattern in what's called a strewn field. The strewn field tends to be an ellipse where the different bits and pieces of the meteorite have fallen. So if you know where some meteorites have fallen, it's usually a pretty good idea to go hunting near those pieces to see if you can find some more as well. Now, in these dry lakes out in the Midwest, out in the Southwest, the surface often is stable for thousands of years. So something that falls on that dry lake could be hanging around for thousands of years, and as a result, the occasional falls that happen, the occasional meteorites that drop in, they're going to be there for a very long time, and they tend to accumulate on these dry lakes. That's exactly what people have done, by the way, when they go hunting in places like northern Africa. And all these spots out here in various spots in northern Africa, you get to one of these places where it's an extremely dry area. And let's see if we can find any where the Martian meteorites have been found, or lunar meteorites have been found around here. It's an extremely dry area, and the surface is stable for thousands of years. So if you go hunting around out here, it's pretty easy to find. Well, it's not easy to find. You've got to spend a lot of time driving around in very wild areas. But when you see those dark rocks on the surface, you can stop and check them out and see if they really are meteorites. Once you do find a meteorite, there's a variety of ways of getting them checked. NASA, I believe, still has a deal where it'll check a rock that you found to tell you whether it's a meteorite or not. Part of the deal is if it really is a meteorite, you got to give them a piece of it so they can add that to their database. But be that as it may, it's still a cool thing to do. You also don't have to go hunting for meteorites where other people have been finding meteorites. For example, those dry lakes that we looked at, which are off the main highway between Las Vegas and Los Angeles, like right here on this dry lake, there's a lot of places where people have already been hunting for meteorites, and so it may be hunted out. But you can always go to some of these other locations that are harder to find, like up here in different parts of Death Valley, which are distinguished by having nice flat dry lakes where you don't even need a four-wheel drive vehicle to go hunting around, driving around them. And you can see if you can find some meteorites on your own. So I hope this is helpful. I remind everybody that Manifold Viewer is free. You can download this meteorites.map database from the downloads page of the Download Viewer page in the Manifold map. It's completely free. Double-click it open and enjoy using it. A few words about how we've organized it here. We can, if we want to add things, if we want to take layers away from the table, we can right-click on the layer and choose Delete from Map. Right-click layer, delete from map. Right-click layer, delete from map. We double-click a layer to turn it on. We double-click a layer to turn it off. If it's kind of faded letters like that, the emphasized letter, the layer is off. If we want to drag and drop a new layer into the map, we can do that at any time. For example, we click on the drawing here and drag and drop it into the map, and we just added the Martian meteorites layer again. Zoom to that layer. And layers to the left are above. So the Martian meteorites layer right now is not visible very well because it's below the transparent streets layer, and it's below the meteorites layer. So if we move it to the left, the icons that are in that layer will pop up above the green icons. We can also double-click on a particular drawing and open it up in its own window. So there it is without being in a map. It's not a part of a layer. It's in its own window. If we Alt-click on the heading, we undock the window, and we can click this, and that'll zoom to fit the whole thing. If we Alt-click on one of these icons, that'll open up an information pane that tells us the name of the meteorite and some other places, some other information about it. We click this to close that window. Then as we double-click to open again, we Alt-click here to undock it. Alt-click on the title bar to dock it again. The actual tables for these drawings are here that give you full and complete information in tabular form. I'm not going to get into those because you'll have to learn more about Viewer using the other videos that are on the Manifold Sales channel on YouTube to learn about how to use Viewer. Right now we're just here to browse this and to see all the different cool locations where meteorites have been found. So enjoy, and goodbye from Radiant Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.